So we had this whole big room of people who had never worked with science before, cutting legs off of cockroaches and hooking them up to this little cheap kit that allows you to then do a variety of things. You could play a record.
That is Britt Wray, and this is Tiny Conversations. I'm Brian Colley. Britt is a researcher, scientist, radio producer, and super intelligent person. Britt recently returned from South by Southwest, a conference in Austin, Texas, where her and her friend Nadia were delivering a presentation on backyard scientists to a group of educators. I hadn't really heard of this before, so I decided to sit down with Britt outside of a coffee shop and ask her what a citizen scientist really is. Here's that conversation.
I know you went to Austin.
Yes.
And I have no idea why you went to Austin.
I went to Austin because there was the big major adult frosh week / conference of big ideas that is South by Southwest. And my friend Nadia and I went down to give a workshop on citizen science, open science, backyard science, biohacking. There's all sorts of things that you can call it, but essentially it's when science is done outside of institutions. There are a variety of different public community laboratories that people have opened up around the world to be able to play around with genetics, for example, without the necessary educational credentials like having a PhD to be able to do that. So there's basically this global movement of people doing science on their own terms, sometimes with licenses, depending on the country that you're in that might require it to do genetic engineering, for example, or just in a more rogue underground sort of way. So our actual workshop, we gave an overview of what DIY science is right now in the 21st century, and then we brought these open source electrophysiology kits, which are called Backyard Brains, that my friend Nadia works with in her job at Harvard. And these kits allow you to hook up a simple specimen and then control and manipulate its neurons. We used cockroaches, so we had this whole big room of people who had never worked with science before, cutting legs off of cockroaches and hooking them up to this little cheap kit that allows you to then do a variety of things. You could play a record, like a real actual LP or something, by manipulating the barbs on the legs of the cockroach and then triggering the electrical conductance of its neurons to then have an output which controls something like the record player or make its own natural noises. And basically we're just trying to create this causal relationship and show people that there are these accessible ways that you can start to learn about neurophysiology. Here's one way, and then of course we talk with them as we're doing it, and we have ethical conversations about using a specimen like a cockroach, which has a life of its own, to be able to teach humans how to do citizen science. Because there's this crisis in America, so they say, the policymakers, that there isn't enough STEM education, literacy, so science, technology, engineering, and math. In Canada, we have a very similar conversation, and one way to make it more enticing is to lower the barriers of entry and not make science this big, scary, inaccessible thing.
That's awesome. Those are really good goals and everything like that. I'm interested in sort of the outside of the I guess the next step. Okay, now the barriers are lowered. What's sort of the bigger goal beyond that? Like, what does lowering the barriers to entry hopefully result in?
Right, like what's the point? Why would you be doing this?
Yeah,
there's so many extensions that people are using this for. So in this age of big data and biomonitoring, measuring everything, you might come across this in your workouts and people checking their pulse all the time or looking at their galvanic skin response or the conductance of their skin and how much it's reacting based on their metabolic activity, or even people are making brain wave sensors like EEG, electroencephalography headbands that will tell you what kind of state your mind is in, whether you're more focused or more relaxed. And a lot of these citizen science initiatives are part of this movement of like the quantified self. So using big data that we can track and lift off of our bodies are these natural processes that are invisibly happening all the time, but then being able to have some sort of insight about our internal states and then potentially control them to a certain extent for optimal living. You want to be able to have a choice as to when you're feeling more relaxed or more concentrated. And sometimes through citizen science initiatives that are actually hooking you up with these biomonitoring kits, people are starting to make those choices in their lives. But it's environmental sensing. Say you've got a lake in your neighborhood that you are worried has some pollutant coming into it from a corporation nearby. By having DIY spectrometers that can measure contaminants or any sort of material in certain samples, you can then start to trace over time how a certain tailing pond or like water pool is changing, and then be able to upload that and share with other citizen scientists and work on each other's research to be able to make a dent or make a claim.
Yeah, it's what's interesting is as you're sort of saying all this, I'm thinking about myself, and I've realized, I've just kind of casually and organically fallen into a category of activity that I didn't even know I fell into, which is, as you put it, a citizen scientist, because on my phone I've recently been monitoring all of my activities. And one of the things that which is very unique for me, and I think maybe this is possibly because I'm not a traditional scientist, is the idea of collecting a bunch of data without really having some sort of, this is what I'm trying to figure out at the end of it. I'm like, okay, I'm collecting all this stuff, but I'm not 100% sure why I'm doing it.
Right. Yeah, absolutely. And that's a huge part of the scientific process. It's an open-ended kind of emergent thing that starts to happen. You might have a hypothesis, but along the way you're finding all these splits in the roads from your discoveries that are going to lead you in another direction, much like when you're going to create a piece of art. You might start improvising with what arises out of all the like small micro movements that you make on your canvas, and then all of a sudden it's something that you didn't expect to happen. But you can't at the outset necessarily claim that you're going to know where these experiments take you, and that's an important creative force that does lead to discovery. I mean, citizen science is not something to hype up. I'm not trying to say it's remarkable or revolutionary. It's exciting because it's a return to the backyard scientist, to that leisurely Sunday scientist, which eventually does amass a particular type of knowledge which is valuable. And so there's a lot of hype around citizen scientist as though it's some sort of really sexy new education strategy. It's always been there, but now it's happening with more purpose and more politics around changing the barriers to entry of science.
Now, on the flip side, and you brought this up earlier, which was some of the ethical sort of concerns, being responsible. I'm just picturing a bunch of people who sort of are like out doing experiments and maybe aren't thinking about some of those ethical considerations. So what would you say are things, or when you were teaching your course even, what were some of the things you were telling people like to keep in mind?
Well, a big area of citizen science that raises eyebrows is biohacking or DIY biology. So this is when we're actually tinkering with DNA and doing fairly simple genetic engineering experiments, but still without necessarily regulated lab controls. And what if you make something that gets out into the environment and can invade a natural ecosystem because you've synthetically engineered an E. coli strain to produce ink, for example. Like a biohacker that I was interviewing and actually just recording a piece about earlier this morning at the CBC has been working in a squat outside of Paris, in the suburbs of Paris, that he's turned into a do-it-yourself biological laboratory. And his project at this stage is not involving genetic engineering. What he has done is harvested large amounts of these bacteria that produce ink that are found naturally in South America, and they produce this pigment, and he's turned it into an ink that you can siphon off, and he's trying to construct a pen, a bioreactor pen, so that you feed the pen, and as a result, the bacteria produce the ink for you, and you never have to change your ink cartridge. That is something that people try to do with genetic engineering. That is, they could take the genes for that capability in that microbe and then splice it into another organism that can grow quicker and then produce more ink. And if that were to escape a laboratory and maybe infect some natural ecosystem, it wouldn't necessarily be a good thing. It wouldn't necessarily be a bad thing either, but because nature is messy and chaotic, we don't know what would happen. But around biosafety, biosecurity, that's that is a legitimate concern. Bioterrorism, what if you get the wrong hands on the right technology? You can say that about any technology. It can go in a myriad way of directions. It's up to the people who are using it. So we need to develop an open yet secure set of community protocols to make sure that the technology is done right. And that's what biohackers are doing internationally.
Tiny Conversations is a podcast featuring small discussions on big ideas. If you've liked what you've heard, you can subscribe in iTunes or Stitcher. Our theme music is by Broke for Free. If you're curious and want to do your own backyard science experiments, you can go to DIYbio.org or symbiota.org. You can also follow Britt on Twitter at Britt Wray, BrittWray. I tweet at Brian Colley. Thanks for listening.